Welcome to Escape Velocity Space News. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. Trying to figure out how to fit 2 weeks of news into our 30-minute format is usually pretty straightforward. Some shows we might have to leave out a couple of stories we really liked, and sometimes we have to scrape the barrel and write about things that just don't get us very excited. It's all good. This week, there was a far too much news problem, and unexpectedly, it came largely from space hardware instead of from space science. Last week, we saw the last flight of Virgin Galactic's Unity suborbital spacecraft, the first crewed flight of the Boeing Starliner capsule to the International Space Station, a more successful launch test of SpaceX's massive Starship, the successful landing, loading, and liftoff of Chang'e 6 at the moon, and the beginning of the end for the HST as it shifted into single gyro operations. We can't go into detail on all of this, but in this week's Closer Look, we dive into all the efforts underway to explore the moon. We also look at a rapid-fire series of news stories covering everything from new science about the asteroid Dinkinesh to Pluto's oceans and a shockingly good ground-based image of Io. All this and more is coming to you right here, right now on EVSN, a product of CosmoQuest, supported through Patreon. We're going to start today's show with some not great news. In a June 4 telecon with the press, NASA shared that due to recent issues, they have made the decision to operate HST in single gyro mode. This isn't expected to have any impact on the quality of individual science images. However, Hubble will need significantly more time to get on target as it relies on imaging to refine its pointing significantly more than it has in the past. It's estimated that as much as 25% less science will be possible, which is still a lot more science than could be accomplished without Hubble. Sun willing, we should still have many more years of data from Hubble. Our staff has heard expressed concerns that solar activity could necessitate a highly risky reboot sometime in the future, however. We will update this story as we get more information. While the 33-year-old Hubble struggles, the not yet 1-year-old Euclid spacecraft has released its first science images. Euclid is a 1.2-meter telescope with a wide-angle camera that is designed to survey galaxy shapes and study dark matter and dark energy. It is expected to work for 6 years. While image releases are always fun, this particular release is accompanied by promises of a stack of 10 new publications concerning what has been found in these images, including free-floating planets, new extragalactic star clusters and dwarf galaxies, and extremely bright galaxies shining at us from the early universe. We look forward to bringing you these discoveries as they are published. And meanwhile, on Earth, the Large Binocular Telescope has installed a new high-contrast optical imaging instrument dubbed SharkViz. Using adaptive optics, the system can compensate for the Earth's atmosphere, and with a pair of 9-meter mirrors, it has resolutions and light-gathering capabilities that allow it to do what were previously considered impossible tasks, like imaging Io with enough detail that we can expect to see changes in lava fields as Io's volcanoes flow over and change its surface in the decades to come. We often find ourselves saying that science moves at the rate of technology. With new telescopes and spacecraft, we can get new views on the universe. and some of them are weirdly unexpected. Back in November 2023, the Lucy mission flew past the asteroid Dinkinesh on its way to Jupiter's Trojan asteroids. This was meant to be a casual chance to get a bit of extra data on one more asteroid. Data that would help us understand more about the frequency of rubble piles versus more solid objects, and improve on our senses of what kinds of surface features and morphologies we can find in the asteroid belt. What we didn't expect to find was a tiny snowman of a moon, a contact binary, peeking out from behind Dinkinesh. The images from Lucy have now been analyzed, and in a new paper appearing in Nature, researchers describe how that tiny moon, now named Salem, might have formed from a landslide. They note that there is a weird trough on the asteroid and suggest that a chunk of the asteroid shifted and dug a trough while flinging out bits and pieces as it made its escape. Well, some of the excavated material may have fallen back to the surface of Dinkinesh. The remaining material went on to form that little moon. While amazing data is the start of amazing research, it takes a lot of calculations and models to truly understand what the data mean. 9 years after the New Horizons mission flew past Pluto and discovered it has mountains of ice and strangely cracked landscapes, a new paper in the journal Icarus with first author Patrick McGovern tries to explain what was seen. They look at Pluto's ice in detail and consider what kinds of an internal ocean is required to both cause the cracks and bulges we see, support the surface, and fit with the shockingly cold temperatures of the outer solar system. They find that beneath a 40 to 80 kilometer ice shell, Pluto likely has an ocean with a density similar to Utah's Great Salt Lake, or about 8% more dense than seawater. Up next, we take a deep dive into humanity's return to the moon. Stay tuned. I am a post-Apollo baby. Throughout my entire career, I've listened to the stories from senior researchers about how they watched men walk on the moon and thus became astronomers or planetary scientists. Me? I watched science fiction and decided if I wasn't going to fly among the stars, I'd study them instead. Over the years, I've heard a fairly consistent tale from these elder scientists. They thought they'd grow up to live in a world where space exploration was just an everyday experience, one that included the same kinds of research stations on the moon that we've had for so long in Antarctica. While they didn't get to see this kind of an exploration in the prime of their careers, it seems they may be building this kind of a reality as a parting gift for the generations coming up behind them. Right now, NASA has plans to land 4 humans on the south pole of the moon no earlier than September 2026. Parallel to the U.S. efforts, China is looking to land 2 humans by 2030, and India is working toward launching their first humans to space on locally constructed hardware in the next few years, as they too work toward potentially putting people on the moon. This new space race is leading to next-generation hardware development, as well as the funding of science in support of these future landings. As so often happens when large amounts of money are involved, the path toward humanity's lunar future isn't without questionable actions, risks, and a few explosions. Actual, literal explosions. NASA has been working on plans to fly beyond low Earth orbit, or LEO, as at least a background task continuously since the Apollo missions. In 1989, George Bush called for the construction of the space station Freedom, which would serve as a jumping-off point for the Moon and Mars. The designs of the time included facilities for on-orbit construction, making the space station not just useful for getting beyond LEO, but also necessary. With the collapse of the Soviet Union and changing political winds, plans for the space station Freedom were scrapped in favor of the International Space Station we have today, a station without construction facilities. Under the Clinton administration, NASA was directed toward robotic exploration, with the commercial sector being called on to step forward as the U.S. government looked for ways to move, quote, away from international launch quotas toward an international commercial environment characterized by free and fair trade in commercial launch services, end quote. It would be the second President Bush in 2004 who would demand a return to the moon, stating that, quote, America will return to the moon as early as 2015 and no later than 2020 and use it as a stepping stone for more ambitious missions. A series of robotic missions to the moon, similar to the Spirit rover that is sending remarkable images back to Earth from Mars, will explore the lunar surface beginning no later than 2008 to research and prepare for future human exploration. Using the Crew Exploration Vehicle, humans will conduct extended lunar missions as early as 2015, with the goal of living and working there for increasingly extended periods, end quote. While 2020 has come and gone without the imagined missions, it is actually this edict that set us on the path we're on today. The Crew Exploration Vehicle from Bush's plan became NASA's Constellation program, which included the Orion capsule and the Ares 1 and Ares 5 rockets. And Ares 1 was actually tested in 2009 before Obama canceled the Ares rockets for being over budget and behind schedule. The Orion capsule, however, continues to be developed for deep space travel and adapted for use on the Artemis program atop United Launch Alliance's Artemis rocket. This program was given new energy under Trump and has been continued under Biden. Under the new plan, NASA is using commercial suppliers to provide rockets, landers, and more through new fixed-fee contracts. For decades, NASA would contract companies to innovate technologies and pay for the complete development and manufacturing process in addition to paying a fee. This meant that companies could become wildly over budget and extend development times for years, with NASA picking up its bill. For decades, this kind of a model funded aerospace companies who manufactured technologies exclusively for NASA. With fixed cost contracts, companies are incentivized to get things done on time and on budget, so they don't lose money on government contracts. And they are also incentivized to find commercial uses for their goods, so that more customers can allow them to better cover their costs and potentially turn a profit. This idea that NASA is just another customer for aerospace companies is baked into the new commercial space era, and it is both facilitating important changes and causing new issues. For instance, by providing contracts for space launches to both SpaceX for Crew Dragon and Boeing for Starliner, NASA for the first time in history assured that the USA can't be grounded when one kind of spacecraft is grounded. It also means that when one program gets delayed, like Starliner, other technologies can allow programs to continue forward. It is clear this kind of a model has worked well with SpaceX Crew Dragon, which is also seeing use by private spacefarers through the Inspiration 4 Axiom series and future Polaris Dawn flights. Starliner, however, has only just managed, several years late, one mission to the International Space Station. At the time of this recording, it is still docked and slated to return no earlier than June 18th. This new model is going to take companies and Congress time to adjust to. And Congress is finding it has to adjust. When Congress doesn't allow more than one vendor to be used, as it initially decided to do with the human-rated lunar lander for Artemis, we are all left hoping that development that must be motivated by more than just a federal contract will find needed business, and also won't get distracted by its other business needs. In April 2021, NASA awarded SpaceX a fixed-cost contract of $2.89 billion to develop the human landing system variant of Starship with a goal of landing 2 people on the moon in each of 2 separate missions. The intention is for an uncrewed lunar landing to take place in 2025, with a human mission landing no earlier than September 2026. Until recently, there was no funded alternative, and as we watch SpaceX continue to not quite get a Starship back to Earth without damage, people like me, well, we become concerned that they won't be able to build the needed craft and develop the needed on-orbit refueling technologies on the required timescales. If SpaceX doesn't, then NASA will need to continue to fund their own Artemis-related activities in different ways for different periods of time, and those kinds of costs ultimately mean that funding won't be available for other tasks. Put simply, in a closed budget, overspending in one area means loss of funding in other areas. SpaceX is currently slated to provide hardware and support to the Artemis 3 and 4 lunar landings. As of May 19th, there is a new player joining in for Artemis 5. NASA awarded Blue Origin and its collaborators a contract for Artemis 5 to provide services on their Blue Moon lander. Like SpaceX, they are also expected to do an uncrewed test landing. This $3.4 billion contract comes 3 years after Blue Origin sued NASA over their original decision to select SpaceX instead of Blue Origin for the landers. Artemis 5 is slated for March 2030. Uncrewed missions of its Mark I version designed to carry cargo are slated for 2025, with a larger Mark II for humans coming later. The Blue Moon lander is a smaller and more conservative spacecraft when compared to Starship. Its development began in 2016, and it is designed to launch in the fairing of Blue Origin's New Glenn rocket, which is expected to launch for the first time in September of this year, 2024. It will measure just 16 meters tall and carry payloads up to 20 tons. While size is the biggest difference between Starship, HLS, and Blue Moon at first glance, a much deeper difference stands out when economics are looked at. Starship is being designed as an Earth-to-space reusable vehicle for launching satellites and more, with the additional goals of one day carrying humans to Mars and, somewhere in there, also doing ferry work carrying humans between the lunar surface and space. These are a lot of goals to rest on the fins of one spacecraft line. At the same time, Blue Moon is designed for one thing: delivering things to and from the surface of the moon. And its partnership between Blue Origin, Lockheed Martin, Draper, Boeing, Astrobotic, and Honeybee Robotics hint at future lunar mission plans beyond just Artemis 5. And it is the promise of other kinds of missions that makes the next generation commercial flights so intriguing. Yes, NASA is currently the primary contractor for lunar exploration in the U.S., but that can very well change. It may be that one day the cost of going to the moon will make it possible for researchers to fly lunar experiments with the ease that we now fly sounding rockets and weather balloons. I'd guess we're a few decades from that future, but for the first time in my life, I can dream of that future and be glad that the future the boomers expected, Gen Alpha just might live. This week, I really only had time to go into detail on the U.S. lunar program and changes in our space program here through NASA. This is what is close to home to me, literally, as an American. But it is important to remember that China is systematically completing their own checklist toward human travel to the moon. Today, they have their own space station, and they have been systematically progressing from orbiting the moon to landing and even returning lunar samples. Chang'e 6 launched on May 3rd, landed on the moon on June 1st, and then took back off with a sample of moon rocks on June 3rd, with an expected return to Earth of June 25th. I have no doubt their plan to land humans by 2030 will at least be close to on time. A new space race is on, and this time, the competitors are a mix of nations and corporations and dreamers. There are always dreamers when space exploration is the goal. Up next, we'll look at the latest news from the launch pad. Stay tuned. This week, Eric is out sick, so I am bringing you his report of tales from the launch pad. First, on May 25th, Rocket Lab launched the first of 2 pre-fire satellites for NASA out of their New Zealand launch site. The mission was named Ready, Aim, Pre-Fire. Let's watch the launch.
5, 4, 3, 2, 1. Beginning pitch over.
Pre-fire, or polar radiant energy in the far infrared experiment, is the first time that infrared radiation will be measured from the Earth's poles. The mission consists of two 6U CubeSats carrying thermal infrared spectrometers launched into slightly different orbits. The different orbits will allow the mission to track changes in the poles on a time span of hours. Data from the pre-fire satellites will fill in climate model gaps to help scientists understand why the Arctic is warming much more rapidly than the rest of the planet. On May 27th, North Korea attempted to launch another Klolima-1 rocket with a reconnaissance satellite on board. The launch failed for an undisclosed reason. On May 28th, SpaceX launched the EarthCare satellite for ESA and JAXA. EarthCare, also called Earth Explorer 6, will measure the Earth's clouds, aerosols, and reflected and re-radiated solar radiation from the sun. Let's watch the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2,
EarthCare features 4 instruments: the backscatter LiDAR from ESA, the cloud profiling radar from JAXA, the multispectral imager from ESA, and the broadband radiometer, also from ESA. ESA's backscatter LiDAR is the highest resolution LiDAR to ever fly in space. The launch and booster landing were successful. EarthCare will have 3 years for its primary mission. On May 29th, Chinese company Galactic Energy launched their third Series 1S rocket carrying 4 commercial satellites. The Series 1S is a modified version of the Series 1 solid-fueled rocket adapted for ocean launching off of a special barge. The launch was successful. On May 30th, Russia launched the Progress MS-27 resupply spacecraft from the Baikonur Cosmodrome in Kazakhstan. It carried 2,504 kilograms of supplies to the station, docking on the Pyoisk module on June 1st. Let's watch the launch.
The engines and turbo pumps coming up to flight speed. And liftoff. Liftoff of the Soyuz booster Progress 88 beginning its delivery run to the International Space Station. Soyuz booster pitching downrange, arcing out to the northeast from the launch site. All engines up and running in good shape. Good vehicle structure reported. Performance nominal, according to the launch conductor at the blockhouse in Baikonur. Yaw, pitch, and roll, all nominal. Good structural parameters on the Soyuz booster.
In that 2.5 metric tons of supplies included dry cargo, fuel, water, and nitrogen. On May 30th, China launched the PacSat MM-1R satellite on a Long March 3B rocket from the Kaishan spaceport. The satellite will provide TV broadcast, broadband internet, regional GPS augmentation, and other services for the Pakistan Space and Upper Atmosphere Research Commission. Let's watch the launch. The satellite weighs 5.4 metric tons at launch and will operate at 38.2 degrees east longitude for at least 15 years. On May 30th, Galactic Energy launched another Series 1 rocket, this time the road mobile version, for the Jiaquan spaceport in China. Let's watch the launch. The mission, called HEROES, consisted of 2 satellites which will test laser communications between satellites. It also carried 3 other satellites for a commercial weather monitoring constellation. On June 4th, Rocket Lab launched the second pre-fire satellite in the constellation, only 10 days after the first, after a minor delay caused by an out-of-family sensor region. Thanks, Rocket Lab. The second pre-fire satellite mission was named Pre-Fire and Ice. It's identical to the first satellite. For the third Series 1 launch of this episode, Galactic Energy carried 4 satellites into polar orbit. 2 of them will test new satellite components, such as star trackers, gyroscopes, magnometers, etc. Nothing is known about the missions of the other 2. We want to take a deeper dive as we look at the Boeing Starliner crew flight test. First, the crew. Like Crew Dragon's Demo 2, this mission will only carry 2 astronauts instead of the vehicle's usual complement of 4. The 2 crew are Sunita Williams, who became the first woman to pilot a spacecraft on its first crewed flight, and Barry Wilmore, a veteran of 2 previous space flights. Both have significant test flight experience from their time in the U.S. Navy prior to becoming selected as astronauts. This mission reuses the capsule from the first orbital flight test, which was named Calypso by Williams. Let's just say Boeing has been working on this mission for a while now. The first uncrewed flight test was in 2019. It was mostly unsuccessful, but the capsule was recovered successfully. The second uncrewed flight test was in 2022. It also had some more minor issues, but was able to dock to the International Space Station and stay there for a few days as planned. The commercial crew program was delivered under fixed-price contracts, meaning Boeing has to eat billions of extra costs due to the delays and reflights. The crew flight test was then planned for 2023, but was delayed to 2024 after some minor parachute issues and flammable tape was found on certain wiring harnesses. Crew Dragon also used this tape at the time. The first launch attempt for this campaign was on May 6, 2024, but was scrubbed 2 hours before launch due to a faulty valve on the second stage of the rocket. It turns out it had exceeded its service life and was easily removed and replaced. While the vehicle was back in the assembly building, Boeing engineers discovered a very small helium leak in one of the 28 propellant manifolds controlled by the RCS thrusters of the service module. The leak was so small it could increase by several orders of magnitude before becoming a problem, so it was not fixed. On the second launch attempt on June 1st, the vehicle got into terminal count, but aborted at 3 minutes 50 seconds after one of the 3 ground computers failed to sync up with the other 2. Turns out it actually did sync, but 6 seconds too late. This was later traced to a faulty backup power supply on the 3rd ground computer. It was removed and replaced. The third launch attempt on June 4th was finally successful. Cruise to the International Space Station was uneventful except for the discovery of additional helium manifold leaks. The crew of Suni Williams and Barry Wilmore conducted several manual piloting demonstrations of the Starliner capsule. Another minor issue happened closer to docking and caused a delay of over an hour. The computer failed off 5 healthy thrusters due to hitting pre-programmed limits, set conservatively for this test flight. They were easily re-enabled, but it was troubling to note that the thrusters in that exact location failed during the 2022 uncrewed test. Starliner's service module is not reused. Docking was achieved at 1:34 a.m. Eastern Time. Starliner will return to Earth no earlier than June 18th. The other mission worth talking about in detail is the fourth SpaceX Starship test. Let's watch the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2. We have liftoff. Vehicle is pitching downrange.
Starship launched on June 5th, following a short delay past its original launch time. If it had launched right at the beginning of its window, it would have likely passed 300 kilometers below the free-flying Boeing Starliner headed to the International Space Station, as both were above the Indian Ocean. The mission was deemed a success for SpaceX's incredibly narrow test objectives. The pad survived, and the first stage and Starship both conducted soft landings at their expected downrange locations. One engine failed on ascent, and another exploded on relight during the booster landing burn. No in-space relight or mock payload deployment were planned or attempted with Starship. During re-entry, the forward flaps on Starship had large holes burned into them from heating. Tiles were observed liberating themselves off the structure, and the flaps were nearly ripped off the vehicle entirely. But it somehow landed softly off the coast of Australia. The FAA is unlikely to start a mishap investigation, as both vehicles landed in their designated hazard areas and no major anomalies happened, so the next flight may happen fairly soon. Elon Musk has said they may attempt a booster catch on land during the next flight. We track launches with the help of RocketLaunch.live. So far this year, the United States has had 66 launches. China has had 27, New Zealand has had 6, Kazakhstan, Russia each have had 4 launches, Japan has had 3, India and Iran each had 2 launches, North Korea had 1 launch. This makes the total number of launches so far this year 114. Finally, there are 10 toilets in space. Before we go, we'd like to take a moment to celebrate the lives of 2 space science greats who have passed away. On June 7th, Apollo 8 astronaut Bill Anders died when his Beechcraft T-34 Mentor crashed into the water near Jonas Island. He was aged 90. While Anders never walked on the moon, he created one of the most enduring images of the Apollo program with his December 24, 1968 Earthrise image. Taken on their 4th orbit of the moon, this image wasn't part of their planned actions, but rather Anders saw that their orbit was causing them to witness the Earth rising over the limb of the moon. And like any excited tourist, he took photos, even asking his crewmates to please get him the color film that was still rare in those days. This image continues to be used to remind all of us just how small we are in the vastness of space. On June 9th, Edward C. Stone, the former director of NASA's Jet Propulsion Lab and longtime project scientist for the Voyager mission, died at age 88. Stone had only retired from his role with Voyager in 2022 and had continued to work on projects, participate in interviews and events, and mentor those around him all the way to the end. And that is it for now. Good night, everyone. And remember to look up. Oh, and please give this video a like and subscribe so the algorithm tells you and the world when new science is ready to be learned.